This is a film on qualitative evolutionary design, Interconnecting Ethelbergar, by Cian. The aim of this project is to interconnect the housing estate of Ethelbergar to the surrounding area, and to connect different generations and people of varying background together whilst addressing the future problems the area may encounter. The evolutionary design workflow that has been developed and will be shown in this video functions like this: areas of intervention, otherwise known as the input, and the qualitative topic are first chosen. From the input, we collect images from online or site visits. For the qualitative topic, we conduct interviews and research case studies relating to the topic. Having conducted more research, the qualitative topic may be altered or changed. After the input and topic have been sufficiently defined, a selection of images which best show the area of intervention are chosen, as are a distilled list of keywords which highlight the values of the users of the input. The image population is uploaded into RE image generation software and regenerated using the value keywords as the text input. This process is to create a series of quick sketches to review and react to. Separately, a defined criteria to which to evaluate the population is established, and a means test with a group of participants takes place to ensure consistent evaluation. This process aims to translate empirical experience to numeric data. The highest scoring images are then evaluated, and successful patterns and design ideas are identified in each of the criteria areas using human evaluation or RE software. The patterns and ideas are then combined with additional human design and inspiration, which results in a final design solution. The solution can then be re-evaluated in a means test and the succeeding steps to fine-tune any specific areas. Using the streetscape as our input and interconnection as our qualitative topic, a workshop and site investigation allowed the creation of a mood board and the selection of our chosen values keywords. The fact that Ethelbergar may be subjected to future flooding was also chosen as a value point. Within the input of streetscape, a further breakdown of 3 areas of intervention was made to target different street typologies, routes, plazas, and intersections. Intersections were defined as crossings of cars, services, pedestrians, exercise, bikes, and nature. Routes were defined as residential, commercial, and public, whilst plazas were defined as open areas consisting of lawns, grey space, courtyards, garage or shed areas, parking or a landmark area. The plazas of Ethelbergar and the surrounding area were first analysed and chosen, then all potential routes connecting them were analysed and selected. The intersection of these routes were then able to be marked. There was also the recognition that certain plazas held more importance as nodal centres of resident and commercial activity. The potential idea of a defined exercise route throughout the neighbourhood was noted early. Whilst pushing the car parks to the edges and underground of the estate was formulated during the workshop, there was also the need for service vehicles to enter the area. Finally, an area of focus which contained all typologies was selected for the demonstration. This is the image population from the area of focus, which have been taken from Google Earth and been generated and adjusted using the value keywords to create recognizable features of an urban landscape, such as paths, parks, and lakes. The qualitative criteria system for each of the 3 areas of intervention was created, leaning on past qualitative studies, and 6 criteria for each area was decided. There were 3 common criteria of nature, engagement, and amenities, and subheadings were used to guide the identification of each of the criteria. For the route empirical system, legibility, accessibility, and safety were chosen alongside the common criteria. For the intersection empirical system, visibility, sociability, and safety were chosen, while for the plaza empirical system, flexibility, sociability, and enclosure were chosen. For an input image, each criteria point is scored as either high or low, based on the empirical experience of the evaluator. These high/low scores directly translate into numerical values which are used to score each image. The later iteration of the system included an n/a option with a corresponding value of 0, to accommodate uncertainty or AI image obscurity. The means test exercise used in the study was completed by 16 individuals, 3/4 of whom worked or studied in the field of architecture or urban design. They were presented with the previously shown population of images. As a control, 3 images were inserted that had been positively altered with the addition of street art, public amenities, and nature. The altered images scored higher than the originals, pointing to a successful evaluation system. The data from the image population was then mapped using radar graphs to easily distinguish successful generations and their areas of strength, with the highest scoring images being selected for the next stage of morphogenesis. This recreation shows how each image was printed off, analyzed with sketch roll and pen to highlight certain features which seemed to influence people's empirical interpretation were noted. Features such as clearly bounded footpaths, flanking tree avenues, narrow and walkable streets, water features and reservoirs, playing fields, colorful path surfaces, certain spatial arrangements of the plazas and tree configurations were some such examples. Following the pattern identification, there was some human inspiration included, notably drawing from the boardwalks found in wetlands and the strip of grass found in the center of country roads, an inverse pair which shows human ability to create pathways in most natural environments and for nature to find a way into the most hostile human paths. A case study of Eddington in Cambridge was also studied, with all 3 topics being seen as potential landscaping tools for combating floods in the area. For the final design stage, a schematic map of the streetscape plan was produced and the focus area of the study was again narrowed to the main area of the Ethelbegar estate. This area includes Ethelbegar Tower Plaza, Rosenau Road Route, and the Rosenau/Petworth intersection. The schematic map was transferred onto axonometric drawings, and the potential of flooding was addressed. This part of the final solution was singular human design with no AI intervention. Beneath the streetscape surface lies a stepped flood drain made of impermeable material, which funnels excess water into a pipe system. The pipe may carry the water to a reservoir or filtering system for reuse. The drain is filled with replaceable gabions filled with sod or turf with a suitable rock aggregate to prevent soil runoff. These act as natural filtering devices to treat the grey water and reduce chemical processing at a later stage. Public pipes and wire carriers are moved into the solid step structure. The pathways are placed on top of the artificial wetland and are composed of permeable structures, which could be similar to rubber mats, honeycomb bricks, and permeable concrete. The streetscape could appear similar to this above ground, using vegetation to divide pathways, a clear pattern from the population, and using trees to break the visual barrier between pedestrian and vehicular movement. The sidewalks have been combined to allow for one large path containing amenities. The road system is one-way and only to be used by service vehicles, with broad bike roads and stepping stone crossings for the private house. The intersection at Rosenau/Petworth demonstrates more of the attempts at social interconnection. The broad walkways cross at one instance, encouraging more spontaneous social interactions and reducing road crossings to just 2. The exercise route highlighted in purple snakes around towards Battersea Park. When we bring in more detail, we can see dedicated seating areas near the intersection, a heavily traffic-calmed streetscape, and vegetation strips with high levels of biodiversity. We can also show the potential of fielding green roofs, with large solar panels to partly power domestics and any pumps used in the flood prevention system. These solar panels trays would also act as rainwater collectors which would filter into the main flood pipes. Moving up to the Ethelbegar Tower Plaza, we can see the spatial arrangement. A mixture of a sheltered area for reflection and a more formal square for socializing allows for a variation in how people interact. The water system is symbolically connected to a water fountain in the tower lobby, which is seen as a vital part of the streetscape and a place for interconnection. The wetland extends into the play area of the children's yard to give the youth a first-hand experience of biodiversity and connection to nature. The inclusion of playing fields scored highly in the population, with intergenerational connection an important value. The reservoir was a recurring fixture in the AI population and could function as an echo pool during the summer months, as a place for the community to swim together. A small waterfall would reduce any water stillness and create oxygenated air for healthy pond life in the lower pool. This final design solution offers a brief look at how a qualitative evolutionary workflow may be implemented and carried through to a concept. Thank you for watching this film on qualitative evolutionary design.